Hi everybody, and welcome to our next video on solving a system of equations by the elimination method. So think about what elimination means. Elimination means to get rid of something. You eliminate it, you get rid of it. So that's what this method is going to be about. And this seems to be a student favorite. You've already done the graphing method. You graph two lines and see where they intersect. So if you love graphing, and the equations are easy to graph, that's a great method to use. We've used the substitution method. Some students really like that. But this third method, the elimination method, again, seems to be a fan favorite. So let's just get right into it, and I'm going to teach you how to solve a system by elimination. So example 1 says solve the system using the elimination method. And here's my system. 2x plus 5y equals negative 4. 4x minus 5y equals 22. I want you to think about this question. What form of a linear equation are both of these equations in? What form? You can pause the video and come back. Think about it. What form are both of these equations in? And I hope you're thinking or saying out loud to yourself, standard form. Standard form. Axe body cologne. AX plus BY equals C. And the elimination method works best when your equations are both in standard form. And the reason is the X's are stacked on top of each other, the Y's are stacked on top of each other, and the constants are stacked on top of each other. And so what ends up happening in this first example, look at these Y's. See how you have a positive 5y and right underneath it you have a negative 5y? Well, if you simply draw a line here and add these two equations together, the Y's are going to eliminate. So check it out. If we take 2x plus 4x, we get 6x. And if we take 5y and add a negative 5y, the additive inverse property will say that those cancel out or eliminate. We bring down the equal sign, and now we add negative 4 plus 22, and that's 18. So now we have 6x equals 18, and we divide by 6 to solve for x, and we get x equals 3. See how simple that was? We eliminated the y and solved for x. Okay, now to find the y, because every solution to a system has a ordered pair as the answer, x comma y, we're going to plug x equals 3 into either of our original equations and solve for y. So I'm just going to take the top equation. So if I take 2x plus 5y equals negative 4, and I substitute in 3 for x, I'll have 2 times 3 plus 5y equals negative 4, which will give me 6 plus 5y equals negative 4. And solving this equation for y, I'm going to subtract 6 from both sides, which will leave me with 5y equals negative 10. And if I divide by 5 on both sides, this leaves me with y equals negative 2. So my final answer to this system is going to be my solution, and it is going to be x is 3 and y is negative 2. And I'm going to grab a pen because I can see this pencil is not showing up too good here. So this is my solution. Now, I'm not going to make you do the next step on every problem, but on this first one, I just want to show you that if you want to check your work, we know that the solution to a system is the point that makes both equations true at the same time. So I'm going to fill this solution in to both the top and bottom equations and see if we get true statements. So if I take the top equation, I'll have 2 times 3 plus 5 times negative 2 equals negative 4. Well, let's see if that's true. 2 times 3 is 6. 5 times negative 2 is negative 10. And 6 plus negative 10 is negative 4. So that first one checks out fine. Okay, let's try the second one. So I'll draw a little squiggly line here to separate it. Second equation, 4 times 3 minus 5 times negative 2 equals 22. 4 times 3 is 12. Negative 5 times negative 2 is a positive 10. And sure enough, 12 plus 10 is 22. And so that checks out. So I feel really confident that 3, negative 2 is the solution to my system. Okay, great. Let's go to the next one. Example 2, solve the system using the elimination method. Okay, so we can see that both of our equations, we've got 9x minus 2y equals 11 with 5x minus 2y equals 15. See, they're both in standard form, so I'm already thinking elimination is a great choice here since both are in standard form. But watch what happens here. If I would try to pull the same strategy I did up here and just add the two equations together, let's see what I get. 9x plus 5x is 14x. Negative 2y plus negative 2y is negative 4y. And 11 plus 15 is 26. So I ask you, did anything eliminate? Did anything completely cross out, go away, like it did up in this first example? And the answer is no, it did not. We now have a 14x and a negative 4y. Nothing canceled out. So that strategy right there did not work. So what I'm going to do is I'm going to recopy this problem. So I'm going to kind of X this out. That didn't work. Let me recopy the two equations. 9x minus 2y equals 11 with 5x minus 2y equals 15. So we have to be a little more clever now. We've got to sort of force the elimination to happen by doing something. So here's my thought. You've got the 2y and the 2y. I mean, they want to cancel out. The problem is the only way they can cancel is if their signs are opposites. So while this right here is fine to be negative, we need this sign right here to be positive so that the negative and the positive cancels out. And there's a really easy way to change that sign. We're going to take the entire bottom equation and we're going to multiply by negative 1. Watch what happens. We'll push this equation over and do nothing with it. Leave it exactly the same. 9x minus 2y equals 11. Now downstairs here, we're going to distribute a negative 1. We're going to distribute it here. So negative 1 times 5x is negative 5x. Negative 1 times a negative 2y is positive 2y. And negative 1 times 15 is negative 15. We're going to draw our bar underneath, and we're going to add these two equations. Hopefully now something eliminates. So we've got 9x plus negative 5x. Well, that's 4x. We've got negative 2y plus positive 2y, and there it is. Additive inverse, say opposite sign, same term, eliminate. I'll bring down the equal sign. 11 plus negative 15 is negative 4. Now to finish solving, I'm going to divide both sides by 4 to isolate x. And so x is equal to negative 1. Beautiful. Now to find y, I have to go back to one of my original equations and substitute in negative 1 for the x. So that will look like this. I'm going to use the top equation. 9 times negative 1 minus 2y equals 11. Okay, 9 times negative 1 is negative 9 minus 2y equals 11. Solving this equation, I'll start by adding the 9 to both sides. So that gives me negative 2y equals 20. And I'll finish it by dividing by -2, both sides. So my y will be -10. So my solution to this second example will be the ordered pair -1, -10. And you could go back and check it if you like. Okay, let's flip this over. We've got 2 to go. Example 3. Here we go. Solve the system by using the elimination method. As you can see, once again, standard form for both, so elimination is a great choice. All right, let's just eyeball this. Before we go down some not so good road, let's eyeball this. Will a 3x and a 5x eliminate? Heck no, that's going to make 8x if you add. Will an 8y and a 2y cancel out? Heck no, that's going to make 10y. So I'm going to have to put this puzzle together and figure out a way to make something cancel. Now, I'm already kind of eyeballing these y's. And the reason is you have an 8y here and a 2y. Now, if we can somehow get this 2y to be a -8y, then this positive 8y and a -8y would eliminate. So you got to think to yourself, how can I get this 2y down here on the second equation to be a -8y? Okay, well, hopefully you're thinking if we just multiply the entire bottom equation by -4, that's going to give us a -8y there. So this is what's going to happen. The top equation does not change at all. I'm just going to bring it over. 3x plus 8y equals -1. But the bottom, I'm going to distribute this -4. So -4 times 5x is -20x. -4 times 2y is -8y. And -4 times -13 is positive 52. And now you see it. 8y positive with 8y negative is going to eliminate when we add. So now we just add the rest. So we've got 3x plus -20x. That's -17x. And over here, -1 plus 52 is a positive 51. We will divide both sides by -17. And so x is going to be -3. Okay, we take the -3. We're going to place it back in for x in one of our equations. Again, I'll just use the top one. So 3 times -3 plus 8y equals -1. And that's -9 plus 8y equals -1. So we will add a 9 to both sides. So we have 8y equals 8. Divide by 8. And so y equals 1. Final answer, final solution, -3, 1. Pretty easy. Okay, last one. Example 4. Solve the system using the elimination method. Okay. Check them out. Both equations in standard form. Now look at our stacking. We've got a 3x and a 4x. We've got a 2y and a 7y. And then we've got our 7 and our -8. Now this one is the hardest of the bunch that I've given you so far, because if you look at the 3 and the 4, 3 is not a multiple of 4 and 4 is not a multiple of 3. Same thing with the 2 and the 7. So when you have a scenario where you're thinking, well, I'm not going to multiply 3 by anything to get a 4, and I'm not going to multiply 2 by anything to get a 7, there's a little trick that will work every time. So it's up to you if you like this trick. I think it works pretty well. When you don't have multiples of each other on your x's or your y's, you're actually going to multiply both equations by something. And here's what you do. It'll work every time, by the way. Just look at your x's. See this 4 down here in front of this x? See this coefficient? Take this 4, put it up top. See this 3 right here? Bring it down here. So you kind of cross. The 4 goes up, the 3 goes down. Now what that does, you can see I got a 12 and a 12. 12x and 12x. You could have done it with the y's too. You could have taken the 7 up here and the 2 down here, but the x's are closer to this side, so I just do the x's. Now, one last thing. You know they have to be opposites to eliminate. A positive 12x and a positive 12x is going to add together to a 24x. So what I need to do here is I need to make one of these negative. It doesn't matter which one. Maybe I'll just make the top negative. Okay? Wouldn't have mattered though. You could have made the 3 negative too. So let's push over to our new equations. Now we have a lot of distributing to do. 1, 2, and 3. So this is going to make negative 12x minus 8y equals negative 28. And then when we distribute, we're going to get positive 12x plus 21y equals negative 24. And voila, we should have something eliminating, and we do. Negative 12x plus 12x is 0. Additive inverse takes those away by elimination. Now we figure out the rest. Negative 8y plus 21y is 13y. And negative 28 plus negative 24 is negative 52. We divide both sides by 13, and we get y equals negative 4. Check it out. It's the first time we got y first. Every other example, we actually found x first. This is the first time we found y. So be careful when you go to substitute negative 4 into the first equation. Make sure you're replacing y, not x. So it's going to be 3x plus 2 times negative 4 equals 7. Finishing this off, we have 3x minus 8 equals 7. We're going to add 8 both sides. So 3x equals 15. We're going to divide by 3. And so x equals 5. Beautiful. Final answer, final solution to example 4, 5, negative 4. All right, so this is the elimination method, our final strategy to solve a system of equations. So good luck with your mastery, and thanks for watching.